Hi, this is an AP Chemistry video. We're going to be covering section 8.4 in Zumdahl. We're going to talk about ions, electron configurations, and sizes. So ion size is important when we're talking about the stability of an ionic solid, and it leads to the different properties and anything, even to do with like biological effects of ions. It's not possible to truly define the size of the ions precisely, but we can measure, not as precisely from the center of one ion to the center of the other. So just in general, what this is showing you is the cation is going to be smaller than the atom, the neutral atom. And that's because if you remember, sodium is going to lose a whole energy level of electrons to become isoelectronic with neon, which means it'll have the same electron configuration as a neon. So the cation becomes smaller than the atom that it came from, and the anion becomes larger than the atom that it came from. So in this case, this is chlorine. So originally it's 3p5, then it gains that electron and it does become larger than the original atom. So this is showing you when things are isoelectronic to each other. Let me just see if I have an isoelectronic means that they contain the same electron configurations. So oxygen, if you remember and kind of can think of the periodic table, neon would be here. Oxygen is, it has 8 electrons when it's neutral. It's going to gain 2 and end up with 10 electrons like neon. That's what we mean by isoelectronic. Fluorine is, it has 9 electrons. It'll gain 1 and have 10 electrons and be like neon. These are in the next period down. So sodium, remember, it's going to lose that 3s electron, and then it'll end up being 2s2, 2p6, like neon. So the metals lose electrons and become isoelectronic to the noble gas that precedes them. The nonmetals gain electrons and become isoelectronic with the noble gas that is in front of them. So aluminum will lose 3 electrons, 1, 2, and then end up with 10 like neon. So one thing, so we're going to look at, you can see how the size is varying here. These are measured values in picometers. And we're going to notice that as the atomic number increases, there's a greater attraction for the electrons, and then the ions become smaller. So what does that mean? If you look at the atomic number, which is our number of protons in the nucleus, sodium has 11, magnesium has 12, and aluminum has 13. They all have 10 electrons. So if you think about Coulomb's law, they're all going to have negative 10 for the charge of the negative part of the atom. And then the positive is really the Z, which is the atomic number. So aluminum is plus 13, so it can have a greater force, Coulombic force of attraction. Therefore, that ion is going to be the smallest of the 3. And then you can continue also with the other isoelectronic elements. So oxygen is plus 8. It has an atomic number of 8. And fluorine is plus 9. So that is why oxygen is larger than the fluorine, which it is, because it has less force of attraction for its electrons, because it has a lower atomic number and less positive pull. So in this question, I just want you to do the first part, and I would definitely pause and think about this. So I'm asking you, which of these ions are isoelectronic with argon? So which ones are going to end up with the same amount of electrons as argon? And when I do this, I can see that, I have to double check so I don't tell you wrong, the argon would be here. So these two are going to gain electrons to become like argon, and these three are going to lose electrons to become isoelectronic and have 18 electrons like argon. So let's try this question. So these are all also isoelectronic to each other, or to argon. They all have 18 electrons. And I want you to rank them. Let's rank them first, and then we'll match them to the picture. So I like to assign atomic numbers right away. I know that scandium is plus 21. That's the number of protons. Chlorine is 17. Potassium is 19. Calcium is 20. And sulfur is 16. So based on that, you would assume that the scandium is going to be the smallest ion because it has the greatest positive pull. And the electrons that they're attracting are 18 electrons, the same electron configuration as argon. So scandium is going to be able to pull much harder on those electrons, which will cause it to become smaller. And after scandium, it should be calcium, then potassium, then it should be chloride ion, and then it should be the sulfide ion. So then if I match the pictures, this should be the scandium. This one should be the calcium. This should be the potassium. And this is a little bigger. This is the sulfide, and this is the chloride ion.